So now we are going into the multiple linear regression implementation. We'll be understanding clearly how the parameters are going to be estimated and how the residual errors are going to be estimated and stuff related to that. Right now, I take this batting data again, which we are going to use for multiple linear regression, and I open the same lab exercise. I just copied from lab one and pasted here. Some additional things I'm going to do, which some of the students have already done. Right? So what I'm going to do is, this is entirely the same program, but I open something more here. What is that is, I haven't given the URL directly. Let me open this URL completely for your understanding. Right? Let me take the URL and copy here. Yes. So this is the URL. Right? Now, if you see here, and if I go down here, I have many number of batsman data available here, and it is in my 19th page. I can also go to my first page. I just say here first page, page one. I just click go. It goes to my first page. Right? Now we need to identify what is the difference in my URL. Right? If I remove this page one also, see this is actually the only thing. Page equal to one, and see here from HTTPS to class equal to 2, everything is common, and from template to batting, everything is actually common. The only thing you just refer this page equal to 1. Right now I just click next. Yeah, I just come down and then click the next button. It moves to page. This is page 1 of 53. Now it goes to page 2 of 53. Now it goes here. See here down. It is page 2 of 53. Now I go to the URL and see here. The page number is page equal to 2. Right, page equal to 2. Similarly, if I put here 24, what will come? What will come if I put page equal to 24 here?
Page 24.
Yes, if I put page equal to 24, directly the page 24 will come. That's how the website, this particular website developers have made the URL, right? So the 24th page has come. So only thing that is going to change is this particular part of the URL is going to change. So what I have did is, instead of taking this entirely as the URL, I made it up to this class equal to 2 semicolon. This is URL 1. I'm just breaking the URL into 3 parts. This is URL 1, and from template to type equal to batting, I keep this as URL 3, and this in between, this is kept as URL 2. URL 2 alone will be changing each time. Now I come down and see there are around 53 pages, and I can take all the 53 pages and then do a record. But for simplification, just I go and see what is available in the 53rd page. If I go and see in the 53rd page, what is there? Everything are actually null values, because they are actually maybe some new batsmen or some retired batsmen who are not having those kind of steps. Even retired batsman data will also be available here, but and the thing is they haven't gone for any such innings. So those data will be given as dash. So these dash data we need to remove. We have a separate session for analyzing these missing values and treating the NAs. So the thing is, we can do this extraction completely within a same program. That's what I did here. So I have kept this HTTPS to class equal to 2 as URL 1, and URL 2 as of now it is empty, and URL 3 is template is equal to, right. I have kept like this. Right now, I just if I didn't specify any page, like if I didn't specify the page here, I come down and say I didn't specify any page record here. See, now just I just click enter. If I didn't specify the page ID, it just giving me the first page. See, first page is actually printed if I didn't specify the page itself. So by using this logic, I just derive the first page as an empty URL 2, and URL 1 will be URL 1 plus URL 2 plus URL 3. Combined, I'll get URL 1. I'll say afterwards why I use this flag. I just come down. I just send a variable to the scrap ESPN function. This scrap ESPN function is nothing but the entire function, what is the entire program what we have done in lab 1. I just made inside a function that is scrap ESPN, and it is going to take two parameters. One is URL, other is flag. right? I'll say why what is the use of this flag, right? Now I come down and I just say URL comma 1, right? This flag is initially 1, and from next what I do for I in range of 2 comma 25, we know that range will take the start index up to end index minus 1. So I'm just scrapping the first 24 pages. I'm not scrapping entire. Why? Because I assume that after 25 there may be, I can also put here 54 and scrap all the 53 pages, but I'm not doing that. Why? Because many NA values will be there. But just for simplification, I scrap 25 pages. 25 means 25 minus 1, 24 pages. I start from 2. Why? Because the first page is already scrapped by direct thing, and then I proceed. Inside what I do, I just update my URL to, which will be equal to page equal to is a separate string plus for I in range of 2 comma 25. So I will be initially 2. Next it will go for 3. In each iteration it will increment by 1. So when I is equal to 2, I convert that also into string. So 2 will now be converted into string, and I say what will be the result of this is nothing but page equal to 2 semicolon. Like that I want to bring a string. If I want to bring a string like that, already I'm having page equal to plus str of 2. So now 2 also will be converted into string, and the string concatenation will take place. Page equal to 2 semicolon, right? Finally what I do, I again merge all the URL1 and URL3 are constant. URL2 is now updated. Now I find the new URL is equal to URL1 plus URL2 plus URL3. And just I print the URL to have understanding, because it will take more time to run this program, because it actually scraps every data from each URL. So I just print the URL to understand how many URLs are scrapped so far. Next, what I do, I say scrap ESPN of URL comma 0. Right? So far, so good, except this flag value. Yes, so far it is understandable. So far, am I making it good?
Yes, sir.
Yes. So this is the thing. And once is it now, I'll say what is the use of the flag. Now I have a field like I'm having a CSV writer right row of fields. I'm going to write the fields also. What is field is nothing but the row names, name, span, mat, in, not out, and descending, and those kind of steps. That is actually the field record, right? So this is if I write it several times for each URL, every time one page contains of 50 records, and after completing that 50 records, again fields will come and so on. So this will happen again and again. So what to do after completing this field? One time only it should be happening in the top. Other times it should not repeat. So I just keep a flag equal to 1, and I set when a flag equal to 1 alone, it will print the fields. Once it is printed once, flag will be set to 0. From next time onwards, this fields will not be printed, right? So this is the case. So shall we run this program? Yes, I'm having here the iterator variable is 25. I'll just run this program. Sorry, I just remove this. Sorry, this is not a command line of Python. Now we see it. See, now this page 1 is defaultly scrapped, page 2 is scrapped, page 3 is scrapped, page 4 is scrapped. See, one by one the URL is printed, means that that particular URL is taken for scrapping. We have actually kept the range end index as 25, so up to 24 URLs it will be getting scrapped. So one by one it will be getting scrapped. Now 17 pages were scrapped, 18, 19, 20, 21, 22, 23, 24. Yes. So all the pages were scrapped now. I gave the end index as 25. So up to 24, everything is scrapped. I have the data available here. I just click it and see how many records are being scrapped in the ESPN Crick BAT stats. See here, around 1200 entries are actually present here. 1200 entries came here. For around 24 pages, this much entries are available here. Now, the very good kind of data set with a sufficient number of values is available for me. I can use these values for my regression, right? What is actually intended for today's class is regression. Now I have the data available, the real-time data. I'm not going for any downloadable data. The data is already also generated by me. The data is ESPN, Crick, and BAT stats. Okay. So when I do for multiple linear regression, I say very clearly how to do that. Very simple. Many predefined algorithms are available. Just use that, and we are going to do. So what I am going to take is I'm just going to import pandas because I want to read the data set, import pandas, and I want the matplotlib also to be present, right? So I import matplotlib dot pyplot as plt, right? And I want this also. Next, I want to get my sklearn package also. With sklearn only, I can actually implement all the necessary data. So I take the sklearn package also. Import sklearn dot linear model. I will say instead import sklearn dot linear model. Why? Because I'm going to use linear regression here. Multiple linear regression is not entirely different. When you increase the number of independent variable, it becomes multiple linear regression. So import sklearn dot linear model. So okay, from I just also take only the linear regression from sklearn dot linear model. I import linear regression. Yes. Next, I want to do train test splitting also I need to do. So for doing that, from sklearn dot model selection, sklearn dot model selection, import train test split, train underscore test underscore split. So these kind of package calling and all, we should actually keep it in our mind. Whenever we go for it, we should not think what package should come for us. So it is linear regression. So immediately I should take sklearn dot linear model. It is train test split. Immediately I should take sklearn dot model selection. It should come in our mind immediately, right? So those things we need to remember very deeply. We should not search for those packages what we required and all. Okay, so that is the thing. Now once packages are being installed, next I go into my reading the data set. I just say read the data set. So my data set is present here. That is ESPN Crick bat stats.csv. So I have my pandas library available here. So I say data is equal to pandas, import pandas, as I say import pandas as PD instead of not having like pandas dot, I say PD dot hereafter. So I say PD dot how to read a CSV file. Just to say read CSV. So if I say read underscore CSV, it will read a CSV file. If I put double quotes, it itself will show me what are the data that actually available. I just type here ESPN click bat stats. It's just type a control space. It itself will show me all the options available. So the data file is read now. And if needed, you can put the data.head. I already know this data.head will be used to see the data set which we have downloaded. But I know because I was the person who generated this data set itself. So I already know how this data set would look. So if needed, you can have this. Otherwise, you can actually comment this, not needed. Okay. Because I already know how the data set will look. It will have name, span, and so on. Right. Next, I need to take features. Separate features and target. So what is target? The dependent variable which I'm going to predict, and what is features? All the independent variables, right? I'm going to take this. So I target variable usually I'll name it as y, and what is my target is nothing but strike rate. We know then, and if needed, I will also print this and show so that I'll run this. So you have to see the data set. So this is the data set. So what I'm going to do is my aim is to estimate the strike rate. assume, let me estimate the strike rate. How the strike rate of a batsman will depend. Strike rate is nothing but how fast a batsman scores runs. For example, if a batsman scores 30 runs in 30 balls, he is having 100% strike rate. If he scores 2 runs in 30 balls, then 2 divided by 30, 2 out of 30 only he is striking. That is a striking. How fast a person can hit. In T20s and all, here a batsman will hit more number of sixes, and strike rate will be more than 100, right? So I want to predict strike rate of a particular batsman, right? So I just say data of SR. So see, I'm typing SR because the name present here is SR. So only I'm typing here in double quotes SR. So that is going to be my output variable target. What will be the input features is nothing but same data. I'm not going to take a single data here. I'm going to take multiple data. The strike rate of the batsman depends upon number of innings he played. Innings is nothing but a number. Difference between mat and innings is number of matches he appeared, and innings is nothing but number of times he entered the ground and then played that particular match in a batting. Sometimes a batsman may not get a chance to bat in the field, so that and all is not counted. So I'll take innings. If he played more number of innings, he'll get more experience, and based on that, his strike rate may increase, and his highest score. So if once I reach some highest score, then I'll get some confidence, and from that I can put more strike rate. And average. What is the average score of the batsman? So that is also an important parameter. And those things and all I'll take these three things for predicting the strike rate. So I take. Um, if I want to make it in the inside a list, I make it numpy list. Okay, so I just take it INNS. So going to be the first feature. Second is HS, the highest score. Third is AV, that is average of the batsman. I name it within the double square brackets because it is going to be acting as my array list, right? So it is going to have more number of items, not a single item. So these things are actually scrapped. Input is going to be X and output is going to be Y. So all are ready now. But the thing to understand here is how the data is actually available in that CSV file. You go back to our normal program and see, we always type here something like in the ESPN click info, we type here, when I extract the data, I say I dot text. So when I say I dot text, even numbers will be stored as integers only. Even numbers will be stored as strings only. If it is pure numbers in decimal form, it may be appearing as numbers itself. So there is a need to convert those numbers into integers or those strings into integers. For example, now here 18426 is there. It is not 18,426. It is a string 18426. I need to convert this string into integer. How can I do that is just to take 18426 and put it inside the function of int. Int of 18426 will give me integer 18426. So that's what I'm going to do here for the innings data, high square data, and AVE data. But the thing to understand here is here for highest score and all we are having a data like 200 star. 200 can be converted into an integer, but star cannot be converted into an integer. Star cannot be converted into an integer. So I need to omit these stars. Why star is there in the sense the batsman has scored 200 and still not out. So those things, the stars and all need to be removed. So first let us convert everything into integer, right? So what I will do, I will take the data. So for I in range of len of x of int, like I'll take just x of int or directly. So x of int is nothing but how many innings is there, right? So how many number of innings is there, it will run from 0 to that many numbers. So what I'm going to, because number of innings is equal to number of hs is equal to number of AB. So anything you can put here that for taking the length, so the for loop will run that much time. And now what I will do is I take x of innings ins of I. X of INNS of I is nothing but this is INNS, this particular record. It X of INNS of 0 is 452. X of INNS of 1 is 380 and so on. Likewise, X of HS of 200, HS of 0 is 200 star. X of H's of 1 is 169 and so on. So I just take like that. So what I'm going to put, it is equal to int of the same thing. I just copy the entire thing and then I paste here. Just I'm saying that it is an integer. Just saying it is an integer, right? Next, I know that in the H's field there are some stars also present. So I need to omit those stars. So what I make, if star in X of H's of I. If star is there in H's of I, then what I should make? I should remove that star. Again, I need to remove that star. So what I can make? X of H's of I is equal to X of H's of I dot replace of what I should replace? I should replace star with an empty string. It is not required to assign it to this way because this is an object, so directly it will get updated here. Just for being some more precaution, I just assign it to X again. So this star will be replaced with some empty string. Right now, what I do now, I can once the if condition is over, now 200 star will be converted into 200. Star will be removed. So I'm removing all the special characters. Those special characters cannot be converted into integers. So I remove those things. Next, what I do, I just do the same thing. X of h's of I is equal to int of x of h's of I. So converting it in integer. Right, similar thing I can do here, but when I come into this particular area, I just see here 44.83 and so on. It is by default behaving like a floating point number, so it will be recognized as a normal integer itself. But when I found this is, I tried to change this AVE also to integer, but later I found that AVE is already available as number data type only. It actually showed me an error. So I understand that this is an error, so it is not required to convert it again into an integer. So the pre-process, this is actually a small pre-processing work, converting everything into integer, right? I just type here, convert the string data in the features to integers. We are doing that. Right. Next, what we will be doing once the data is converted. Now that thing is splitting into train and test. Train and test the data split. So I can do the same thing like x train, comma x x test, comma y train, comma y test is equal to. Now I have a function called as train underscore test underscore split. I use that function train underscore test underscore split. It will ask for me the x and y values what I need to split, the data what I need to split. I give him x comma y. I give it to that function, comma. I can also give what is the test size. What is the test size percentage? I give the test size is equal to some 0.40 or 0.30. Right? I did 0.40, meaning that 40 percentage for testing and 60 percentage for training. Right? And I can also give a random state. So randomly it can be getting selected. So random underscore state is equal to 1. Random state is 1. Right? So far so good. I'll also give time for typing. So far I'm making it okay now.
Yes, sir.
Yes. No, now this is actually the splitting. Now that everything is done. Now just we use the predefined data type already available. That is the linear regression dot fit. That fit is actually the function. I'll use that and then I'll implement that into my data. Right now, define the multiple linear regression formula. It is called multiple because multiple features are there. Nothing more different. Okay. Now I say so. The thing is, I can have like linear underscore regression is equal to linear regression of. So linear regression is actually the function. I already included that package here. So this package is included already. So that package I'm calling linear regression of. So my model is actually built in linear regression. I can use this particular model to fit my input and output values. I just have here linear regression dot fit of. I can fit my X train and Y train values. I'm going to fit the training data X train comma Y train. So the training and testing data, sorry, the training X and Y values are being fitted now, right? Now what I can do, I can estimate the coefficient, right? Once it is fitted, I can find what are the coefficient of each of the individual thing. We know what are the use cases of those coefficients and what are the use cases of those standard errors and stuff related to that. So I take those and then I estimate those coefficients. We know how to estimate also. Let us see how the program is giving us the coefficients. So I print coefficients. So I print the coefficients value is nothing but uh, linear regression dot coef. The dot coef is a function which will give me the coefficient which is available. Yes. Yes. I come down. I see the coefficients available. The coefficient is very small, means that this coefficient is not a very good estimate. What is this? Is nothing but innings, number of innings played, and this coefficient is for the highest score, and this coefficient is for AVE. We found that relatively of all the three, AVE is somewhat better. But let us estimate whether these features can properly estimate the strike rate or not, right? So this is a linear regression coefficient. Next, so we know that coefficient is one thing, and we also need to estimate the variance. Variance is also one of the most important. If the variance is equal to 1, it means that the both X and Y are the good regressors, because it means that they are very closely related. Right? Let us see what is the variance. Print variance, and the variance is nothing but let's just say linear regression dot score. So linear regression dot score of X train comma Y train, or I can put X test comma Y test. Anything I can actually put. I'm doing for X test and Y test. Why? Because those are the new records which are going to be seen. The data are not seen so far. So let me put for X test and Y test. Let us come here to the bottom. So the variance is around 0.08, means that X and Y is not that much related to each other. So what I'm coming to explain here is the selection of features, right? Whether I can select these three features as a parameter for estimating the strike rate or not. This is actually very much closer to closer to zero, means that there is no much variance between X and Y. There is no that much variance, but it should be much closer to 1. But I'm not, it is not even more close, even 0.1. We need 1, but it is not even 0.1. So that's what we are actually saying. And in order, so these features are not that much good. And another way for doing that is you can plot and see the residual plots. You can see how the residual plots are working. Let me plot that and show how the residual plots are going to work. In the previous class, I showed you various residual plots. Now I'll show in a real time how those residual plots will behave and help us understand the use of a particular feature. Right? So now linear regression dot I say predicting the prediction of X test. The linear regression dot predict X test. So now the X test is predicted. Now that is available. That is in the X axis, and in the Y axis it should be the linear regression dot predict of X test minus Y test, means that predicted Y value minus actual Y value I need to take. So linear regression dot predict of Again, I say X test, that is X underscore test. Here it's also X underscore test. Once predicted, it should be X test minus Y underscore test. So the difference is, this is linear regression dot predict of X test. This is nothing but the predicted Y value, and Y underscore test is actual Y value. So what I'm doing, this side is actually the actual Y value. So that is a predicted Y value minus the error term. So the predicted Y value minus error term will give you something called as residual error plot. I'm going to plot the residual error plot, right? So that's what we are going to do, and the same thing I can do for testing also. For training and testing, I can do the same. I can also give color. Color is equal to, let me give uh, green color, and I can also say number of spaces to be present here in the particular graph. I say 10 points in x and y axis, and the label for that is going to be test data. I say test data. Okay, let me run this program. See how sparsely my data is being present. This is actually the data, tested data actually present, more sparsely located data, the strike rate data along with the predicted values for testing, right? Now I'll do the similar thing for training and show. I'll give time for you to type also, no issue. So plot dot scatter is just I take the same thing, plot dot scatter. I paste it one more time. Instead of having it for testing data, let me do for the training data. Train, train, train. And for showing the difference, I'll change the color. Let me go for blue color, right? And I change this to label to train data. Let me go down and see how the graph looks. See, now training and testing data. It means that all the training and test data are closely related. Means that they are randomly distributed. My randomness is working here. I'm not doing any bias. All the training and test data are actually equally being aligned close together, right? And the blue color points is more. Why? Because we took 60% for training, so blue color points are more, right? Now I can put a line and then see how the regression curve is actually being working out here. We can also put some horizontal line and see how the regression line is going on, right? Let me put a line in the origin, plot dot hatch line, horizontal lines. Where I'm going to put this is in the y-axis will be 0, and minimum x, and where the x value should start, and at the origin at the y is equal to 0, I'm going to draw a line, and x minimum value will be equal to 0, comma x. Before seeing my x minimum and x maximum value, let me see here what will be the x minimum and x max. If I keep x minimum as some 65 and maximum as some 100, it will be working out well. So I'll keeping like that. X minimum as some 65 and x max as some 100, and line width, I can also specify the line width equal to 2. I can also specify higher line width also. Let me run this. Now let us see how the error line is going on. See, this is actually my residual line closer to the origin, and see how the points are being distributed across train and test. So this is actually your y value, and this is your error. So it means that there are two conditions to understand from the residual plot. This is a residual plot. Your residual plot should be symmetric on both ends. Symmetric in the sense on the upper and the lower level, it should be somewhat same. I hope that it is somewhat same. On the upper and lower level, it is somewhat same. So it is symmetric. But The another criterion for residual curve is all the points should be mostly closer to the line of origin. This is actually the line of origin. All the points should be closer to most of the points. I mean, most of the points should be closer to the line of origin, and only some of the points should be scattered across the line of origin. But here, if you see many points are scattered across the line of origin, means that my prediction is not going good, or the features what I have selected is not working out well, right? So this is the thing I need to explain you how the feature selection for multiple linear regression is working, right? So normally we will be taking some features and we'll be doing that estimation for prediction, and we'll say this much accuracy. But in this course, what we have to understand is how to select particular feature. So instead of directly plotting the accuracy curve, plot the residual plot. In the residual plot, you analyze whether these particular features is working out or not. If needed, I will go up. I'll remove instead of having this. I know that in out of these three, average is having some highest weight, so I'll remove these three. These two things I'll remove from it. I remove it, and let me if those are removed, these things are actually not needed. So I'll remove this. I'll comment these things. Now let us see how the estimate is going on. It became a simple linear regression. For this simple linear regression, see how the plot is. See now it is actually having 27 there, and still my variance is only 0.05. It should be closer to 1. Only when the variance is closer to 1, it means that that particular feature is useful for estimating a corresponding y value. But it is not that it is very, very low. So even average is not a very good estimate of strike rate. So that's what we need to understand here, right? So what we can do, we have many features available in the data set. What we have to do is we need to analyze the feature which is somewhat good to predict the strike rate, because the task given to us is predict the strike rate. How to predict? We have many features available. Try the features one by one and find which is the best feature. Not only the best feature, you can also try multiple features also, right? So instead of doing it as normal linear regression, this is somewhat different. In this course, we need to go as deep as possible. So what we can do have is we can understand how to use the features itself, and we can also do one more thing, like we can also have the control functions available. Control functions in the sense I can also may not make it y is equal to mx plus c alone. I can also make it y is equal to beta 1 x plus beta 1 x beta 2 x squared. Those kind of steps also we can actually try. I will be seeing how to do that also. So let me have a strike rate. You first try this. Sorry, INNS HS my AB. So you can try this, and you try with other features also. So I'm having many features here. See, I'm having best figure, a number of hundreds. So many things are actually here. So which is actually an essential criterion for predicting the strike rate of a batsman. You analyze that. Even you have span. What is this span? Is nothing but experience. So you can actually take this, find a difference between the 2012 and 1989, find what is the experience of the player in terms of years. But there'll be not much difference in using innings or span. So I actually skip this. So either innings or the total run scored, everything will be having an effect on the strike rate. Even the total run scored can be taken as a good measure for the strike rate estimation, right? So I give it as homework for doing that. I'll also do that in the next lab. Now I want you guys to try this. Pandas is for reading the CSV file. Matplotlib.pyplot is for plotting. And I want to use linear regression. So I use sklearn.linear model. And I want to split my data into training and testing. So I use sklearn.model selection. Next, by using that pandas, I read my CSV file. This CSV file is not any file I downloaded from internet. This CSV file is a data which I have generated. So I have that, and data.head means that printing the first 5 rows, and I'm separating the features. What are the features we want? We know how many features are available, and I take the strike rate feature as target, and the feature which I need to predict and analyze, and I take the input as innings, highest score, and ABE, right? But I now I found that these are not that much significant in predicting a strike rate on their own. So we need to analyze what are the other features. Now what we do here is, here we do some sort of pre-processing. What we do here is Here we actually use in the ESPN Quick Info. If you go there in the above program and check in the ESPN Quick Info, we scrapped everything and stored as I dot text. We scrapped everything and stored as text. So even numbers will be printed as strings in my CSV file. Only when it is having some decimal places and having a notation to represent it as number, it will be still present as strings. So I need to convert those strings into integer. How can I do that is just to take that, just to say int of the same number, same thing. So the string will be converted into integer. I do that for innings and the highest score data. For average, it is already present as decimal numbers. So it is automatically recognized as a floating point integer. Converting a floating point again into an integer, it is actually will give an error because in Python, all float, double, everything will be recognized as number data type. Converting a number again into a number is not needed, right? Now I coming to train test split. So a tuple assignment x train, x test, y test is going to be obtained from the function train test split. I give the data. My data is x comma y, and I give test size is equal to 0.4. Means that 40 percentage is for testing and 60 percentage is for training. And I also assign the random state equal to 1. So I mean that randomly you take 40 percentage for testing and leave the remaining for training. I mean the remaining 60 percentage. Now I define the multiple linear regression formula, that is linear regression is equal to linear regression of. How I get this function? I have imported my sklearn dot linear model. See, I have given here sklearn dot linear model. From this I import the linear regression. I take that and I use it. Next, linear regression dot fit of x train comma y train. That's it. I fitted. Only these two lines are actually the machine learning code. Other things are model estimation. Now, when I fit, I get the coefficients and the variance. The model parameters are nothing but the coefficients of each beta 1, beta 2, beta 3. Beta 1 is for innings, beta 2 is for highest score, and beta 3 is for average. And variance, how the parameters with respect to input and output is actually varying. Right? Those things we need to estimate. The variance should be equal to 1. If it is equal to 1, it means that x is actually the very good estimator of y. If it is not equal to 1, if it is equal to 0, it is not having any relation. So now that is actually an essential indicator of whether to use the particular x value for predicting y or not. Next, coming to the plotting, what I'm going to plot is just I'm plotting the residual plots. So far we plotted only accuracy and say, sir, we obtained this much percentages accuracy. Usually that will not be a good sense when we go for a real-time data set. Why? Because in real-time data set, we don't know which particular feature to use as a best feature. So I just plot it as a residual plot. What I do here is I just take linear regression dot predict of x test. When x test is used for prediction, the resultant is the predicted y value. The predicted y value is kept as in the x-axis. In the y-axis, what I take? I take x linear regression dot predict of x test minus y test. So what I said, predicted y value minus actual y value. What is predicted y value minus actual y value? Called as. What is predicted y value minus actual y value called as? Called as error. It is predicted y value minus actual y value is called as error. So I plot the error in y-axis. Now just to put up some green color scatter plots, and they are going to be the size between each of the plots is going to be 10. But there is from 66.5 next to 76.5 like that each of the blobs, and just have the label for the data as test data. Similar thing I do it for training also. So take both the training error and the testing error I'm going to take and then plot, and I put a line of origin here. Plot dot hash line of y is equal to 0, x minus 65 and x max is 100. And even I go as deep and explain why I put 65 here. I put 65 here because when I plotted those things, I found that the line is actually closer to 65, up to 65. It is actually starting from some 68 only. Before that, there is no point. So I just starting from 68 and so on. So I'm just taking like that only, right? And after up to 100, it is enough. After 100, some only one point is there. So I gave only up to 100, right? If you want, you can also place up to some 110. So this point also will be covered, x max. So on line width I keep 2 for line thickness, and this is the thing, right?